Hi everyone, happy Tuesday. I just wanted to make a video talking about wind since wind is the main focus of the chapter this week. And in this week's chapter, you're going to learn about wind barbs, and I'm going to teach you in this video how to use those wind barbs and how to actually forecast the wind a little bit better based on MOS. Since you'll be asked to forecast wind, speed, and direction, especially when it comes to the final forecasting project at the end of the semester. You'll want to understand how to read these charts and how to forecast the wind based on weather models. So I'm going to focus on the Northeast, and I'm going to focus on Boston in particular just because we have quite a potent nor'easter, an early season nor'easter that is going to impact the region late tomorrow and into Thursday. So I picked Boston, and I want to highlight Boston just because this is going to show some really good wind variations and wind speeds, and it's not just going to be plain and boring. So right now I'm on Pivotal Weather, and for now I just selected the NAM 3 kilometer, and remember the NAM 3 kilometer is just a higher resolution, so it gets a little bit more detail in there. And I zoomed in on the Northeast, and for right now I just highlighted mean sea level pressure and then 10 meter above ground level wind. So this would be the surface wind speeds. Now, if you've already watched the wind barb video, we talk about wind barbs and wind vectors. So the main difference between wind barbs and wind vectors are that wind barbs show the direction that the wind is traveling or coming from, and then wind vectors basically just show where the wind is going. So it depends on what weather map you use, but since I've only really shown you Pivotal Weather, and the traditional meteorological community uses wind barbs, sometimes you'll see wind vectors though. So here, wind vectors, they show the direction that the wind is traveling. So the arrows indicate the direction that the wind is going. So in this case, we really just have like a west-northwest wind. You can see the direction that the wind is traveling. But when we talk about wind barbs, if I zoom in a little bit, wind barbs actually show the direction that the wind is coming. So if we look out over the ocean right here in the Gulf of Maine, you can see that the wind is coming out of the north. And what's nice, it's the same way that it works with temperature, is that if you move your cursor over the different spots, you can see the different wind speeds. Now, wind is typically recorded in knots, and the conversion between knots and miles per hour is 1.15. So in the scheme of things, you can really just say knots are equal to miles per hour for right now. Even though they're not, you can kind of just say that, especially since we like to give wind speeds in a range. So you've already watched the wind barb video, so you know how to read these wind barbs, so I'm not going to go into it right now. So here I want to show you how to use wind barbs, and I want to show you how to also compare the wind speeds and direction on what you see here on a weather map to MOS, because that's what it seems like some people are struggling with based on the discussion posts. So here what we notice is that this is Tuesday, so this is 12Z on Tuesday, so that's 8 a.m. So I'm going to zoom in a little bit, and we can see here that the wind is coming out of the northwest direction, and it's fairly light. And it's really just around 4-5 miles per hour, more or less. Very, very light wind. And that's pretty much going to be the story as we move through the day today. So as you can see, that wind speeds, right, they basically are right out of a northerly direction, and then they kind of come out of the west a little bit later on, early this afternoon, and then they kind of, meander all over the place. And this is what we call a variable. So the winds are very, very light, and variable meaning they're kind of all over the place. So there's really no definitive direction when we talk about wind direction. It's just very, very light. But as we go through time, what you'll notice here is that now we're at Wednesday, which is tomorrow at 15Z. So now we're mid-morning on Wednesday in the Boston area, and now you can see that if I zoom in one more time, that the wind speeds are now coming out of the south. See how the wind barbs are pointed down or towards a southeasterly direction. So that means the wind is traveling in this direction. the way that the flags point is the direction that the wind is coming from. And so even as we go into tomorrow here, that the winds are still very, very light, but then as we move through time, now this is evening time on Wednesday, and I didn't mean to click the sounding, but as we move through time here, this is 8 o'clock on Wednesday night. You can see that the winds are now kind of out of an easterly direction. And here is the area of low pressure way down here developing off the Delmarva Peninsula. And this is going to just track just south of New England in a very northeasterly-like fashion. And so here you can see as we get into the overnight hours, so this would be midnight on Thursday. Actually, this is technically 2 a.m. on Thursday. Here you can see that Boston is now experiencing winds of about 30 knots. So it's going to be very, very gusty overnight Wednesday into Thursday as the storm comes through New England. And so this is going to be a very, very potent storm. And, impacts for this storm typically usually would be, especially for this time of year, with the leaves, pretty much still mostly on the trees. This would be, power outages from downed tree branches, and it can really cause quite a mess. Now, these aren't wind gusts, these are sustained winds. Sustained winds means that these are wind speeds recorded for up to a minute. So we're talking, anywhere from 25 to 30 mile per hour winds, sustained mile per hour winds, for the overnight hours. And then as we get through the day on Thursday, they technically lighten up a little bit, but it'll still remain pretty gusty. You can also tell that it's pretty gusty based off of these isobars. You see how these isobars are very, very close together. That means we have a tight pressure gradient. When the isobars are close together, that means the faster the wind speeds are because the pressure gradient is tighter. So that's another indication that these are going to be some gusty winds, even though the wind speeds have relaxed a little bit. So these are sustained winds, and Pivotal Weather also has a wind gusts feature on it. If you go to the upper air, or maybe surface and precipitation, it might not be on, maybe it's on severe weather. Okay, it might not be on the 3 kilometer NAM. Yeah, it might not be on the 3 kilometer NAM. Yeah, I don't think Pivotal Weather actually has the wind gusts. Maybe on the GFS it does. But regardless, I just want you to understand how to read wind barbs and use that information for MOS as well. So here we can see, how the wind speeds have relaxed a little bit. And so now what I want to do is I want to go into a little bit more about how to read the winds on MOS. So here I highlighted the wind lines for you. WDR is wind direction and WSP is wind speed. So wind speed, these would be wind speeds in knots. And as you can see, for the rest of the day on Tuesday, the winds are very, very light. And then for pretty much half of Wednesday or most of Wednesday until we get into Wednesday afternoon, they're fairly light as well. And then they begin to pick up overnight. And here you can see now we're getting into Thursday. So here are the timestamps: 0Z, 3Z, 6Z. So there's 8 p.m., 9, 10, 11, 12, 1, 2 a.m. And here you can see the wind speeds, according to the GFS MOS, are about 20 knots sustained. So now with the wind direction, I think this is what most of you are actually having trouble with. The wind direction is the number of a compass rose in degrees. So if you look at a compass, you have north, south, east, and west. And if we drew degrees on this, north would be 360 or 0, east would be 90, south would be 180, and west would be 270. So if a wind is coming out of the southeast direction, it's about 135. If it's coming out of a southwest direction, it's around 225, so on and so forth. You can talk about northwest, which means it's kind of north, but still a little bit in a westerly direction, and that would be anywhere from about like 340 to 350, more or less, and so on and so forth. So how you relate that to MOS is that the wind direction category is given in degrees, except they don't put the ending number on here. You can see here that this is 30, 31, 31, 13, 16, 20, okay? There is an imaginary 0 there, but to save space on a line, they just don't put the 0 there. So here this wind direction is coming out of 300, 310, 310, and then you can see how it shifts to 130, 160, 200, 200, 170, and so on and so forth. So 300, based on our compass rose, 300 is about a west-northwest direction. So actually, I can move this over a little bit so we can see. So here we have a west-northwest direction, 300. And then it goes to 310, 310, and then you can see here it shifts to 130 right here, which would be later on this afternoon on Tuesday. So this would be late afternoon Tuesday. Here's the timestamp 21Z. So then it shifts to 130 and 160. So 130, okay, would be about a southeasterly direction, and 160, right, would be a south-southeasterly direction. And then here you can see as we go into the overnight, it goes to 200 again, and then 170. So the winds basically start here. They start off the west-northwest direction, and then they go west, and then they kind of come back here, and they go south-southeast, and then they move back to a southwesterly direction. And so this is those variable winds that we talked about when we looked at it on Pivotal Weather. Here you can see on the weather model, if we go back, you can see here the winds coming out of a north-northwesterly direction, and then as we move through time, here you can kind of see that they meander a little bit. So that's that wobbling, that's that variation that we discussed previously. And here you can see the wind speeds are very light, 4 knots, 6 knots, 3 knots, okay? It's not really until we get to tomorrow afternoon that you start to see some kind of trend or some kind of sustainability in the wind direction. So here would be 160, 140, 140, 130, and then as we go into the overnight, it goes 07, so this would be 70 degrees, 50 degrees, 10 degrees, and then it shifts to 270 again. So what the winds look like for tomorrow based on Moss is that if we bring up our compass rose again, 16, right? So that would be 160. So the winds starting tomorrow afternoon are going to come out of the south-southeasterly direction. And then what they're going to do overnight is they're going to move to 70, 50. So now they're going to go from the east-northeast direction. And then this is as the storm's moving through. Then as the storm passes to our north, here you can see the winds move back to 270, 270, 280, 300. Okay, so now what that means is that now the winds go from an east-northeast direction and they move back to the west-northwest. So if we look at pivotal weather, it's just to compare, you can basically see what's happening. So here, right, the winds are coming out of the southeast, south-southeast, and then as we move through time a little bit, now they're coming out of the east, and here is that area of low pressure coming out of the east, and this is very sensitive. I'm sure you've clicked on this by accident a couple times. So now we're coming out of the east, and then as the storm passes to the north, now you can see the winds are starting to shift back towards the west. So that is how you use that's how you use wind and read wind on pivotal weather, and that's how you compare it to Moss. And you can use the same thing when you use National Weather Service grids as well. So I hope that video was informative. It's really early on Tuesday morning, so sorry this is a little bit stuttery, but I hope that helps with any clarification and any questions that you may have, and feel free to reach out if you have any further questions on how to read wind.